Objective number 2, identify even and odd functions from the equation. Example number 2, we want to determine whether each of the following functions is even, odd, or neither. After that, we need to determine the graph is symmetric with respect to the y-axis, with respect to the origin, or neither. Let's recall the definition of the even and odd. We will apply definition in this problem. If the function f is even, we input the x and we input the negative x, we will get the same output. And what if the function is odd? We input negative x, we input the f of x. It have to show they are opposite. That means one is negative of the other. If the problem, when we check odd and even, they do not work, then we will conclude that the function is neither. So for the first one, the procedure to do is we always check the even first. When the even doesn't work, we check odd. When odd doesn't work, that will be neither. So for the first one, what if the function is even? Then we should have f of x equal f of negative x. So we will find f of x, but the f of x is already given in the problem. Now what if f of negative x? We will plug in negative x into the problem. Then we get x squared minus 5. And you can see that they are equal. Both sides are equal. Then we conclude that the f of x is even. When the f of x is even, you do not need to check it's odd or neither because it can be even and odd at the same time. It's just one, okay? In part B, let's check the function g of x even first. If the function g of x is even, we should have g of x equal to g of negative x. G of x is x cubed minus 1. And g of negative x is negative x cubed minus 1. What did I do? I plug in negative x into the x location. And then I simplify the right hand side a little bit. So I got negative x cubed minus 1. You see that they are not the same. So g of x is not even. Now we check g of x. For the odd condition. So negative of g of x is negative of x cubed minus 1. And g of negative x we calculate before is equal to negative x cubed minus 1. So if you distribute the negative for the left hand side, you will see that negative x cubed plus 1 is not equal to negative x cubed minus 1. So the function g is not odd function. Then we will conclude that it is neither. Problem B for h of x. First of all, we check even. So h of x equal to h of negative x. H of x is 5 x cubed minus x. H of negative x is 5 negative x cubed minus negative x. So 5 of x cubed and negative x cubed times you get negative x cubed. Multiplied by 5 is negative 5x cubed plus x. And then write 5x cubed minus x on the left hand side. You see that they are not equal. So it is not even. Now we do the odd case. H of negative x equal minus of h of x. Negative of 5 x cubed minus x. We replace h of x from the original problem. And for the left hand side, we already calculate h of negative x is negative 5x cubed plus x. Now let's open the parentheses. And what do we see for both sides are the same? So this is the odd case, and we check it's satisfied. Then we conclude that h of x is odd. And this problem is problem C, right? Problem D, f of x is absolute value of x. So we will check the even first. F of x equal f of negative x. F of x is absolute value of x. F of negative x is absolute value of negative x. And we notice that we can write negative 1 times x for the right hand side, and then we can separate the negative 1 and the absolute value of x, and it's equal to 1 times absolute value of x, and it's equal to absolute value of x. I use the property in the absolute value. Absolute value of a times b is equal to absolute value of a times absolute value of b. So we see both sides are the same. This is the even case, so we conclude that the f of x is even. We go back to the problem. The problem also wants us to answer that the graph is symmetric with respect to the y-axis, origin, or neither. When it's even, it's going to be the y-axis, right? So in case number 1, we will answer is the y-axis, and case D is the y-axis. When odd is origin, it is symmetric with respect to the origin, and neither, so neither does not symmetric with respect to the y, or does not symmetric with respect to the origin. So we do not have the answer for part B.